Thank you very much for that kind introduction. I've got a little bit of today's talk based on material that I gave last year, not least of all a bit of a discussion on the referring to previous presentation about containers and the fact that Docker runs as root, but that's another matter entirely. Today's talk is on issues, exploring issues on event-based HPC cloud bursting, and this will describe a exploration of activity that we went through at the University of Melbourne, where we've been consistently over the years trying to maximise the throughput that we get from job submissions. That's like being our big goal. So we start off with like some general principles here. A distinction between high performance computing and cloud, which of course is very familiar to everybody in the room. I think the key takeaway messages here, of course, is that although there has been a big development in cloud computing for very good reasons, when it comes to performance, certainly the high performance computing space continues to dominate because of its capability of operating on that bare metal level, providing that high speed interconnect and so forth. There has been a lot of studies done on this over the years, and I reference a few at the end. I put my slides up on the web so people can download and have a look at those papers at their own time. I thoroughly encourage people to do that. And of course, there is always debate about cost issues. We had a very interesting experience at the University of Melbourne way back at the end of 2015, where we had a fairly standard architecture for an HPC system. We had compute nodes, we had a relatively high-speed interconnect, and when it came to the period when we were talking about, well, we need to refresh our system, we asked the researchers what sort of things do they want, and of course we got the responses, which of course we all know and love. They said they wanted more memory, they wanted faster processors, they wanted more interconnect, and so on and so forth. Of course, what they were really saying is they wanted their jobs to run. And that led to a very interesting study aside from that. So apart from doing just the user response, we were looking at actual metrics. And one of the things that we discovered, and this of course is not going to be the case with everybody, one of the things that we discovered is that almost three quarters of the jobs that we were running were single node. Okay, and that's not necessarily the case in other institutions. If you go to Science in Montpellier, for example, they have massive clusters that's based on life sciences work, where they typically will run 2,000, 3,000, 4,000 core jobs for 24 to 48 hours, because that's basically their job profile. So the first thing we say is, well, look at the job profile of your users when you're doing a refresh, because that will actually determine on a management level and an economic level where your purchasing should be. There is no point in buying a high-speed interconnect across your entire system if 3/4 of your jobs don't use it. And it was particularly important in our circumstance because we actually hadn't been given much money. So, being ingenious and how we manage the system was actually forced upon us. So that's the sort of thing that we had developed. So we built ourselves a smaller traditional HPC system, and then borrowed a large number of cloud virtual machines from the Nectar Research Cloud, part of the Melbourne allocation, and we now had a system where it was partially HPC, and as a partition of the HPC through the standard job submission process, we had what we called a cloud partition as well. So we now move towards hybrid HPC and cloud models, and I'm pleased to see that these are actually a lot more common. It was, this dinky little experimental system a couple of years ago, and now I find out that, people all over the world are actually taking more of this into account, which is absolutely fantastic. One of the particularly interesting things, which based on a little bit of a tour of Europe in 2016, was this, the delightful discovery that we were not alone, but people were doing things differently. University of Freiburg, for example, also had a hybrid HPC cloud model, but in a completely different approach to what we were doing. Ours was a bit more simpler. For us, it was just a case of virtual machines, a one-to-one deployment. We found out fairly early in our testing cycle that overcommit was not a good idea. All sorts of issues there, but we went one-to-one deployment, and we used the same deployment scripts that we used for cloud machines and Nectar as we did on our HPC system. University of Freiburg went in a completely different direction. Their approach was to allow the job submission system to spin up virtual machines as users needed. So they allowed for people to have their own images which they could deploy, and that could be deployed as a job. So they actually ended up with a variety of models. They could use the Moab scheduler without running the resource manager in the virtual machine. Or they could use job submission via the OpenStack dashboard, or they could use it within, job submission via the Moab scheduler with a virtual manager running within the VM itself. So multiple models there. We have a joint paper published by University of Melbourne and University of Freiburg that was given at the IEEE last year. You can quite happily go look that up. So we had different approaches there. Now one of the other, again, they had a very similar objective as well. They wanted to provide additional flexibility within their HPC system. They didn't want nodes sitting idle. Our approach, of course, is about providing a high degree of performance, and our flexibility was really about the size of our HPC system. One of the other things that we looked at, which we thought we could do quite happily, would be to actually make use of the elastic computing option that is available in Slurm. Now this sounds delicious. The idea that if your cluster, your HPC system reaches capacity, that a nice little trigger would happen, event-based, that would fire off and make use of an external provider of additional resources. And that would be a very happy and ideal world if this could be done in a relatively seamless manner, where demand, there was capacity spikes that you could actually go out there and do this. And there's good cause for optimism. And I've got to say that the Slurm Workload Manager does this in a very clever way. Basically, it makes use of its power-saving features, where you can basically specify a set of nodes with their suspend time parameter, and when you basically fire that up, you can when you basically hit that triggered condition, it will fire up and reallocate additional nodes. So that basically, that power option becomes also a cloud bursting option. We were in a good situation. As mentioned, we already had a large component of our HP system that was derived from the Nectar Research Cloud. It provided us a good chance to do some experimentation. After all, we could use the same scripts, we're in the same data center, so on and so forth. And we thought, okay, we'll turn on and experiment with this HPC cloud bursting option. We created some petitions, we tested it, it worked, it was wonderful. We thought to ourselves, well, why not turn our entire cloud partition into into a cloud bursting model. That way, we can actually sort of, allocate this as needed. Well, as we know, software is not perfect, despite what the manufacturers of the Therac 11 told us, and code equals bugs. And there you have a picture of the first bug as pasted into the log manual, as it was found on Relay. And we discovered a bug as well, because bugs are a glorious thing to discover. And I'll go into a little bit of this detail here about that bug, because it was quite fun. And I've got to say that the people at Slurm were very, very fast to actually act on it. So what would happen is the Slurm controller daemon would lose the list of excluded nodes and partitions when it did the S-control reconfigure, and then treated all nodes as being eligible for power control, neglecting the suspend exec, and would start to suspending them, putting them into a power saving state. So there was a couple of things that needed to be changed. There was the power save.c, the exec node bitmap variable, etc. And, it was basically fixed fairly quickly. However, it did mean that a large portion of our nodes would not restart once they were powered down. And that's really not what you want. So we decided that once this bug was fixed, that yes, that cloud bursting, that internal cloud bursting did work. We were happy with it. We could expand on that if we wanted to, but we would let it sit for a little while, because, well, it was an additional variable which we did not need, and especially did not need under the circumstances, because it was, fairly easy for us to expand the allocation from the Nectar Research Cloud that we had in Spartan in any case. It was just an additional variable that we didn't actually need to do. So, having done the internal cloud bursting and learnt something along the way, we decided to go another step. We thought to ourselves, well, how about some external cloud bursting? How about this lovely situation where if we hit capacity on our HPC system, which actually happens a fair bit on ours, I often raise an eyebrow when I go to conferences like this, and somebody will come up and says, yes, we've increased utilisation of our system from 50% to 65 or something like that. Well, poor old University of Melbourne, I still don't think we've got enough in our system, because we're often hitting 100%. We often still have jobs in the queue, and our throughput is still getting higher and higher. Last year, when I gave the presentation on our little cluster, I was proud to announce that we had just passed completion of 1 million jobs. Well, now we're up to almost 5 million. We'll probably hit 5 million by the end of the week. I guess that is in part helped by the fact that our small system received a fairly substantial expansion, which I did mention actually at last time, with the implementation of large GPU partition. And in fact, if we could get Limpac to run successfully across the entire system, we would find that we have grown from being a relatively small experimental system to probably about number 200 in the world. So that's not too bad, actually. So anyway, we're getting there. So we thought to ourselves, well, how about external cloud bursting? And we were approached by the usual suspects. No need to name who they are. You all know who are the big public cloud providers. And there have been, of course, various proofs of concept done. People have done studies where they show that yes, we can make use of this, these features in Slurm. They can fire off on capacity, hit that trigger, off they go, allocate jobs to this new partition. Which is all very fine and well on a proof of concept stage, but when we started looking at the details, we realised that there was a lot of problems there. Mostly related to the fact that it's not in your same data centre anymore. Mostly related to the fact that you've got a great deal of distance between you and your external cloud provider. you do actually have with HPC systems a very, very finely grained application tool chains, very specific versions, things which have got a whole range of particular dependencies that have been built in. And replicating that is going to be onerous. Mounting that over a long distance is going to be extremely painful. Grace Hopper used to point out, mind your nanoseconds. So like showing everybody, it's like, about 30 centimetres of a piece of copper wire, and it's like saying this is how far light will travel in 1 nanosecond. 1 nanosecond, and you multiply the distance that you've got to go and the time that you've got to go over that, then suddenly start thinking in terms of the problem. This is not to suggest that researchers don't ask us for things which are a little bit tricky at times, like can I mount my data directory, which is stored interstate, on the HPC? Well, yes. Could I run jobs from it? Well, not a good idea. Same situation here. There's basically either you adopt a mount approach, which would take a very long time to actually do your reads and writes, even if you do take in VPNs as considerations, or you start looking at replication of your software set, which if you wanted to do en masse would be difficult to say the least. So, what are you left with? Well, the approach that we've said is plausible is to actually have a subset. A subset of your full model, wrapper scripts around that, and then you can have a situation where, at the very worst case environment, at least some people will be able to make use of a cloud bursting model when there is peak demand and they are priority users, or there are particular circumstances for that. As mentioned, another feasible alternative, quite feasible alternative here, is pre-configured singularity containers, because of course the singularity container isn't going to care terribly much where it's actually running. Of course, there is building those containers in the first place, but in general, that's something that's we're prepared to accept. Again, however, using the same process. Copying the data back, powering down the node, and so forth. Is there an alternative? Well, yes, of course there is. Good folk at Adaptive Computing with Moab and NODUS have built a cloud bursting model as well. And I was delighted to discover that actually they have encountered all the same problems that we discovered in the process as well. So they have an elastic trigger that uses an API key that builds a template image and then invokes the nodes, all pretty much the same sort of stuff, deploys them, completes the job, transfers the data as necessary. You will note there on their little picture, this is from their own documentation, that they have this little red box that sort of implies, and I think quite incorrectly, the idea of running what looks like a multi-node job, which is partially across your own cluster and partially across your external cloud provider. And on one of their promotional videos, where they got feedback on this sort of thing, somebody asked a question about that, of saying, "Hey, what sort of latency are you really expecting to experience when you do that?" And their tech person said, "Yeah, no, don't do that at all. It's not a good idea." Another thing which you probably can't see on the picture there up the top, Moab will invoke this trigger for cloud bursting when there is a violation of SLAs. Okay? So you know what they're saying here. There's actually not a very strong technical case to do this. All right, there's my sad message. Right? There is not a strong technical case to do cloud bursting from HPC. There may be a very good business case. There may be a very good administrative case to do it. And there may be a small subset of circumstances where you can make use of it. But such is the nature of the beast, sometimes research doesn't always give you the answers that you want. And it comes back to actually a theme that I was exploring last year, where I talked about sort of like the relationship between HPC and high throughput computing, and sometimes you actually get an abstract notion of performance is not as good as the concrete notion of throughput. Well, we have a similar situation here where the ideals of what we would love to see in the cloud bursting and HPC environment are not necessarily what we're currently getting in reality for very good underlying physical reasons. So there is good reasons that we're sort of like saying that you can use this for. We can use it for containerized situations. We can use it in sort of like our long-running jobs where the initial sort of like, process of spinning up the task isn't that great. It can quite happily go off and do that sort of task. We think that it may be good in testing and training examples as well. One of the issues that we have is that each year there's a postgraduate course where a whole bunch of sort of like, new people come online for a short period over a few months, a couple of hundred extra users, and they do all the sorts of things that we know that sort of, new users shouldn't do, like they'll run jobs on the login node and get told off for doing that. So okay, we have to invoke a new login node for them. They will put in all their assignment tasks, which of course will add to the queue, and so on and so forth. There is good reason that we would want to actually put that in a HPC cloud environment instead. So, basically operate that as a cloud bursting situation where they can log in, still get the HPC environment, still have their submission scripts, and by the way, this is the queue that you submit your jobs to. And please don't interrupt anybody else as you're doing so. So, the promise of cloud bursting from HPC, this ideal environment where we could sort of, transparently add extra nodes on demand with equivalent performance is a very long way from the reality yet. However, that's just part of the nature of the beast. Not all research gives us the results that we'd like to see, but it is still useful that we actually do find what limitations are, because they also, apart from providing us that grounded reality that we have to get back to occasionally, it also provides us the opportunity to do further research and improve those circumstances. And just as I suspect that we, several years ago, we saw fairly significant performance hits on HPC versus cloud, and that has been reduced significantly over time. If there is the demand for cloud bursting, I think we'll also see similar sorts of reductions in the future. Thank you. Oh, here's the long list of references you can get, and here's the frog. Any questions? Yes, yeah, Jordy.
I have already architected Cloudbursting for some clients.
Yep.
Okay. So I know the pain that you have.
Okay, yes.
So far until now, but for example, the approach in a store.
Yep.
If you use Cloudbursting as a cloud-based partition, it's not going to work at all. So multi-clustering, replicating the same services they have in on-premises in the cloud.
Yep.
In addition to data staging, is what usually works much better.
So what was that?
Is what it usually works much better.
Yeah.
Because the policies that you want to import in Slum Controller in the cloud are definitely different to what you have in the on-premises, right? And then business rules about it's eligible to run on-premises, and how much time do you want to spend transferring data, or how much data do you want to move around. So it's not easy for a generic center like you are, but there are a lot of potential workflows
Yes.
Like a weather forecast, for example, or something, a weather forecast component.
Something that is more computational heavy than data heavy. Yeah, no, you're right. That's a good point, actually, so like specifying that, yes, some particular workflows are obviously much better suited for this sort of task.
And usually people think on cloud as a virtual machine, like Amazon, Azure. There are some options out there that could be actual HPC facility.
Yep.
Or solutions like Albania or Bernard Global that provide two HPC kind of technology, it's vertical access.
Yep.
And they expose two kind of APIs. One is API based on OpenStack.
Yep.
They offer Slum daemon.
Sure.
Which is much easier.
Yeah, of course.
Just two Slum daemons in touch with the same database.
Yes.
And then it's just a multi-clustering approach of Slum Federation approach.
Yep. Okay, thank you for that. Any more questions? Yes. Hi.
The three quarters of your job's single nodes, that seems to be perfect to move to the cloud, right?
Sure.
Why do you have an HPC system in the first place?
For the other 1/4. Well, actually, no. And also, the other thing was, the other thing was, it was a good organising model. Yeah. You know, it was a good model to basically sort of like have for the software builds. It was a good model for those people who sort of like maybe running these single node jobs and then going, oh, but I also need this application. Basically, it's about getting the compute and data together at the same place in the same environment. So, it's one of those interesting things where you actually sort of like have to sort of compare what is your job profile and in what proportion. And I think that's one of the really strong business cases for sort of like having a hybrid HPC cloud system. Because, you know, if you are running a general purpose compute cluster, either you're going to make a lot of people happy but annoy a small group of power users, or you're going to make the power users very happy and annoy everyone else. By having that level of partitioning, where you have different sort of like hardware capabilities, you'll have a more cost-efficient and hopefully a happier user community. Well, good. Okay then, thank you once again.